Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 9 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3343, count number of balanced permutations. Okay, so let's read the problem statement first. You are given a string num. A string of digits is called balanced if the sum of the digits at even indices is equal to the sum of digits at odd indices. We have to return the number of distinct permutations of num that are balanced. Since the answer may be very large, we have to return it modulo 10 to the power 9 plus 7. And what is permutation? A permutation is a rearrangement of all the characters of a string. Okay, so problem statement is very easy, right? But this problem is marked as hard, right? So there is a reason for this. Okay, so actually this is going to be a little bit lengthy. Okay, code is going to be a little bit lengthy, and there are multiple things inside this, and this question is very important. Okay, very important question, right? So here, see this example number 1. So this is your nums array, right? 1 2 3, right? So in this nums array, okay, so here size is 3. Okay, n is equal to 3, right? So how many different permutations I can make of this 1 2 3? So one is this 1 2 3, right? One is this 1 3 2. Okay, one is this 2 1 3, and one is this 2 3 1, and one is this 3 1 2, and one is this 3 2 1. Okay, so there are 6 permutations, right? So see here, total 3 digits are there, right? So here I have 3 choices to fill. Okay, so I can place 1 here, I can place 2 here, I can place 3 here. Okay, 3 ways, right? And here at this position, if I already add 1 digit here, so only 2 are remaining, so here I have 2 choices. Okay, and same way in 2 places I have filled 2 digits, only 1 is left. Okay, so here 3 into 2 into 1 is nothing but 6. Okay, so 6 ways, right? 1 2 3 4 5 6, and I can also say that this 6 is nothing but 3 factorial. Okay, 3 factorial ways, right? Okay, so but here notice one thing, none of the digits are repeating. Okay, 1 is one time, 2 is one time, 3 is one time. Okay, but here see this case 1 to 1. Okay, now tell me the different permutations of this one. So you are going to say that one is this 1 to 1, one is this 1 1 2, and one is this 2 1 1, and that's it. Okay, that's it. So only 3. So why here we are getting just 3? So here see how we are going to calculate then the total number of permutations. So total number of digits here 3, and here 3 factorial, and here 1 is how many times? 1 is 2 times. Okay, 2 factorial, and this 2 is how many times? Just 1 time. Okay, so 1 factorial. So here it is nothing but 3. Okay, it is going to give you 3 only. Okay, 3 into 2, and it is going to cancel out, and you are going to get 3 only. Okay, so this is clear, right? How we calculate the number of ways. Okay, so to calculate the number of ways, what we need to do, the total number of digits, right? So here 3 factorial, and we just need to write the frequency of all the digits, right? 1 is just 1 time here, 2 is just 1 time here, and 3 is just 1 time here. Okay, that's it. So it is going to give me the number of ways. Okay, so here in this case we are going to get 6, and in this case we are getting 3. Okay, that's it. Now here what we need to do, here we have to check, you are given a string num. A string of digits is called balanced if the sum of digits at the even indices is equal to the sum of digits at odd indices. Okay, so here if I write it like this, 0 index, 1 index, 1 2 index. Okay, so 0 and 2 are even indices, right? And 1 is odd. Okay, 1 is odd, and 0 and 2 both are even, right? So here let's do one thing, mark this even as in this green color. Okay, so these are even indices, right? Even indices, even indices, even indices, right? Even indices and even indices, and mark the odd in this color pencil. Okay, so these are nothing but odd indices, right? Okay, so now here you see a string of digits is called balanced if the sum of digits at even indices is equal to the sum of digits at odd indices. So now see this case. So even indices sum is 3 plus 1 4, and here we are getting 2. No, this is not balanced. Here 1 plus 2 3, so this is valid case. Okay, this is valid case. Okay, sum of even indices is equal to odd indices. Okay, so 1 plus 2 3, and here also 3. Okay, so this is valid, right? Same way this is not valid. This is valid. Okay, this is also valid. So 2 plus 1 3, even this sum is 3, and here at odd index we have 3. So yes, this is valid. This is not valid. Okay, this is not valid. This is also not valid. Okay, so output is 2. So distinct permutation of nums are these one, and among them 1 3 2 and 2 3 1 are balanced. Thus the answer is 2. That's it. Okay, right? So this is what we need to do, right? We are going to use these many terms in today's video: binomial coefficient, modular inverse using Fermat's Little Theorem, factorials, fast explanation. Okay, so I have already explained these terms as part of this Leetcode 2338. Okay, so if you guys want to know these terms in detail, then go ahead and watch this video. But in this video also I'm going to explain only few things, not in detail, but for detailed explanation you can just go ahead and watch this. Okay, so here, see here what we are doing. Total sum first. What is the total sum? Okay, total sum, it should be equal to the sum at the odd indexes plus sum at the even indexes, right? And I am saying that sum of odd indexes uh, is should be equal to the sum at even indexes, right? So let's say this is x. Okay, sum at odd indexes, it should be equal to sum at even indexes, and let's say the sum is x only, right? So here total sum is going to be x plus x, and it is going to be 2x. Okay, so here when we multiply anything with 2, so we are always going to get even number, right? So here what is the value of total sum? We are getting 2x, right? So here, from here, one thing is clear now, that if sum is even, okay, only then the result may possible, may not be possible. But if the sum itself is odd, then we can't divide the sums in odd part and sums in even part equally, right? So here if it's 13, then I can't write here 7.78 and here 6. Okay, no, it is not valid. But if it is 12, then it is possible, and I can place 6 here and 6 here. Okay, because we need equal values, right? 2 into x. So if my total sum is not equal to even, right, then result is not possible. Then from here you can simply return the that result is not possible. Okay, you can simply return 0 from here. But if it is even, then we have to check different possibilities, then maybe result is possible or not. Okay, so here see 2x 12. So here at sum of odd indexes, if you have 4 and if you have 8, then result is not possible na? Only with 6 result is possible na? So this we need to check. But if it is odd in the starting itself, then result is not possible, simply return 0. Okay, so this is one point, right? Okay, so this is clear, right? So now here see one more thing. Here let's suppose you have terms like this: a, b, c, d and e. Okay, so these are the terms. Okay, so here this is your string. Okay, so here how many total places are there? Total places are 5. Okay, so n value is 5, right? So now here if I just give the indexing 0, 1, 2, 3, 4. Okay, so here tell me the even indexes. How many even indexes you have? So number of even indexes you have here is 0, 2 and this 4. Okay, so 3 in total. Okay, 3 even indexes: 0, that is nothing but 0, 2 and 4. And how many odd indexes you have here? So odd indexes 1 and 3. Okay, so only 2. So here you are going to mark 1 and 3. Okay, only 2 are there, right? So now here let's suppose if this is your string. Okay, a, b, c, d, e and f. Okay, something like this. So here how many total places are there? 6, right? So n value is nothing but 6 in this case. And here this is if I just give the indexing 0, 1, 2, 3, 4 and 5. Okay, so even are these 0, 2 and 4. Okay, 3, right? And odd are here 1, 3 and 5. Okay, so 1, 3 and 5, right? So now here, from here I can see now, I can make one formula, right? If my length is odd, okay, then I will consider even length as n plus 1 divided by 2. Okay, so here see now 5 plus 1 divided by 2, I'm getting what? I'm getting 3 only, right? N is 5 now, so 5 plus 1 6 divided by 2 3. Okay, so 3 length I am getting. Okay, so here I have to add n plus 1. Okay, so here in this case also just do n plus 1. Okay, for even also you have to do n plus 1 do by 2. Okay, so here 6 plus 1 7, 7 divided by 2, again you are going to get 3 only, right? So this formula is right here. Okay, and here for odd, this is for even length. Okay, even length is 3. Now for odd length just n by 2. Okay, so here n by 2, if you do 5 divided by 2, you are going to get nothing but 2. Okay, so see odd length is coming out as 2. Okay, so see this is the formula, right? N plus 1 divided by 2, odd is n by 2. Here also for odd just do n by 2. Okay, so n by 2 is nothing but 3 only we are going to get, so 3 is the length. Okay, so this is the formula that we have derived. Okay, so how we calculate the even number of indexes is nothing but n plus 1 divided by 2, and odd index is n by 2. Okay, so this is a simple formula that we have to use. Okay, so from here it is clear now. If length is odd, then we are taking even as 3 only, right? So here I can't use directly n by 2 because I will get 2. Okay, so I need here 3, so that is why I'm adding plus 1. Okay, so n plus 1 divided by 2. If I do that, so here I'm getting 3 also, and here also I'm getting 3. Okay, and same way here n by 2, if I do, I will get odd as 2 here and here 3. Okay, so from here these two are important point. Okay, e is equal to n plus 1 divided by 2, and odd is n by 2. Okay, so this is done, right? So this is clear. Okay, so now here let's suppose you have this string a b a C and D. Let's say this is a string. Okay, so for this string, okay, I'm not considering number side, no. Okay, because in problem statement it is given that our num consists of digits 0 to 9 only, but let's first understand with this characters value. Okay, A C B A D. Okay, so from here we one thing from here length. Okay, first even indexes. Okay, even indexes are 0 1 2 3 and 4. Okay, so even indexes here you have 0 2 and 4. Okay, so these are the even indexes you have. And what are the odd indexes? So 1 and here 3. Okay, these are the odd indexes, right? So here you have to calculate the total number of ways now. So here n plus 1 by what is this length, n plus 1 divided by 2. Okay, so here number of ways, how you calculate the number of ways? So you calculate number of ways as n plus 1 divided by 2 factorial. Okay, this factorial you need to do. And how you calculate the odd number of ways? So odd, here what is the length? N by 2. Okay, so n by 2 factorial, right? So here how you're going to calculate the total number of ways? So total number of ways, okay, if I just want to calculate the total number of ways for this, so I know now. So total number of ways for this one is going to be what is the length of this? N is equal to 5. So you are going to say that n factorial. Okay, n factorial, right? And here you also need to write the duplicates, right? A is occurring how many times? 2 times. B is occurring just 1 time. C is occurring just 1 time, and D is occurring just 1 time. Okay, so this is the total number of ways. Okay, but here I need some ways here. Okay, this is for even and this is for odd. Okay, so here in these indexes, okay, only have to fill the values. So how many ways will be there? N plus 1 by 2. Okay, so here I'm not considering any duplicate right now. I'm just considering the number of ways. Okay, so here n plus 1 divided by 2 factorial, and here n by 2 factorial. Let's suppose you have string like this: a b c d e, all are distinct. Okay, I'm considering this case first, right? So here n plus 1 divided by 2 factorial, and here n by 2 factorial. Okay, these are the ways. Okay, so here let's suppose abc, here you are using, let's suppose abc, and here you have possibility you can use de at 1 and 3 index. Okay, here at 0 to 4. Okay, you are using abc only. So here this is one way, right? And here you can also write it like same thing like this na, acb, and here you can de. So see, with the same set, okay, you are going to get this as this is one possibility, right? Right, abc acb. Then from here also, you if you are using bac, then here again this is possibility bac de, this is one combination. Then again with bac also, this is also one combination if you use ed. Okay, so number of ways here. Okay, and with all the ways, okay, here there are so many ways. Okay, there are so many ways here. Let's suppose x ways here, and here also y ways are there. Okay, y ways. So if you select this way here, then with this way, this way is also possible, this way is also possible, this way is also possible, this way is also possible. Same way if you select this way here, so with this way also this is possible, this way is possible, this way is possible. Okay, so what we are going to do? So total number of ways is nothing but n plus 1 divided by 2 factorial into n by 2 factorial. Okay, so just multiply these two, right? So this is nothing but total number of ways considering even indexes and odd indexes. Okay, so here you have derived one formula. Total number of ways, total number of ways is n plus 1 divided by 2 factorial, right, into n by 2 factorial. Okay, this is the formula that you have derived. Okay, but here we are not considering the duplicate case. Okay, that also we need to check na. So here maybe this a occur 2 times in this side. Okay, there is possibility na. So right now here if you see, frequency of a is 2, frequency of b is just 1, and frequency of d is just 1, and c is 1. Okay, so here there is possibility na, this a occur 2 times here, this is one possibility. So that simply means here if I write this here, so in even indexes, even index in a occurs 2 times, then definitely in odd indexes it is going to occur 0 time only, right? because we have to use all these numbers now, all these characters, right? And same way, if in even it occurs just one time, then in odd it is going to occur one time. Okay, there is also one possibility, if in even it just occurs zero number of times, and in odd it occurs two times. Okay, so we have to check all these cases now, what are different possibilities, right? If it is occurring two times in the even side in even indexes, or if it is occurring one time. So if it is occurring two times in even indexes, then we have to do it like this now, 2 factorial here, right? And if it is just occurring one time here in the even indexes, then we have to do 1 factorial. Okay, so and if it is occurring zero times, then we don't need to do anything. Okay, all right. So here same way, here also if it is occurring two times in the odd indexes, then we have to do 2 factorial here. Okay, so that is a little bit complex. Okay, how we are going to find out that here it is occurring zero time first. So we have to check all these cases, right? If it is occurring zero time here in the factorials or one time in the factorial, right? We have to check all this stuff, right? So just first make this point. Okay, so this is important point. Okay, this formula, so this is nothing but this is going to give you the total permutations. Okay, total permutation that you have, right? So now after that, what you need to do, you have to calculate, right? You have to calculate the number of ways, right? So here how you're going to write. So here see, if a frequency is 2. Okay, a frequency is 2, so you have options now, that in even you can place either it zero time, maybe you can place it one time, maybe you can place it two time. Okay, so this is a possibility you have. So you are going to just run for loop. Okay, so here for you can say int I is equal to 0, and here I is less than. So here you have possibility na, until 2 only you have to check. Okay, so 0 time, 1 time, or 2 time. Okay, so this is what you have to do, and here you have to just increment it. All right, so inside this you have to check na, total ways. So here even number of ways you have to calculate. So even number of ways is going to be first here frequency 0. Okay, if this 0. Okay, 0 number of ways. Then odd you are going to calculate. How you are going to calculate? So frequency of this 2, frequency of this digit a. Okay, frequency of this digit a. So here from here you have to just subtract the I value na. So definitely na, if you are using here it is 2, so then here this is nothing but 2 minus 2. Okay, 2 minus 2. Then here if it is occurring one time, so here this is nothing but 2 minus 1. Okay, so that is 1. So total frequency is 2. So if in even you are using 2, then here 0 left na. So that's a simple thing. Okay, we have calculated the duplicates, right? So in even how many duplicates we have, and in odd how many duplicates we have. So how we write the duplicates? So we write duplicates like this now, 1 by I factorial. Okay, and here 1 into frequency of this a minus I factorial. Okay, so this is nothing but for even, and this is for nothing but for odd. Okay, so this is one case, right? This is one case where my a is occurring 0 times in the even indexes. Okay, 0 times in the even indexes. Okay, so here in that case, how many total number of ways? Okay, using this half you can say half permutations we are calculating, right? We are just dividing the dividing them into half, like this is even and this is odd. Okay, so half indexes, right? So how we are going to get? So total we are going to get like this only, right? So here n plus 1 divided by 2. So here n plus 1 divided by 2 factorial, and into n by 2 factorial. Okay, this is a total base. Okay, so now for one case a is equal to 0, right? So here for this you have to divide it with multiply, or okay, you can simply multiply and just assign this variable, let's say ways or duplicate ways, something like that, and just multiply it with this duplicate ways. Okay, so here values are going to come like this now, n plus 1 divided by 2 factorial into n by 2 factorial, and here you can simply write this as 1 by into 1 by this I factorial. Okay, and here you are going to write it as 1 by this frequency of a minus I, okay, factorial. Okay, this is what you need to do, right? So here we have added a duplicates now, so that we get the correct number of ways. Okay, so this is for one case. Okay, 0. So here may a occur just one time. Okay, that is also possible, right? Then we have to check, then also we have to check now, if a occurs two time in the even axis, then also we get the some number of ways. Okay, so we have to just make sure that we have to add all these number of ways again and again. Okay, so if this is a result, then the result is equal to result plus equal to this. Okay, so we have to add all these scenarios, right? But here one thing you have to make sure, in your problem statement you know that the constants are given as 0 to 9. Okay, so you are going to use the digits only, right? So first you 0, okay, you have 1, you have 2, okay, 3, 4, 5, okay, 6, 7, 8, 9. Okay, so let me tell you how your recursion is going to work in this case. Okay, so these are digits. Okay, so here 0, let's say zero's frequency is 2. Okay, so for first you are going to check for 0, right? So here you are going to run one loop and you are going to check for 0. Okay, so frequency of 0, then 1 for first for 0, then after that 1, 2. Okay, all these frequencies you have to check. Okay, so first, like this is 0 is equal to 2. Okay, so you have some even indices here and you have some odd indices here, right? So you are going to check again all scenarios. If you are placing 0 only one time in the even indexing, okay, if you are placing 0 times in the even indexes, or if you are going to place 0 2 times in the indexes. Okay, so you have to check all these scenarios, right, one by one. So and you have to just do the here addition, okay, again and again. All right, so here one thing, right? So here this is what you need to check, right? 0 if you are placing here, right? All this thing. Okay, so now what you need to do, so you are going to run one loop. Okay, 0, 1, you are going to check all these numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, as soon as you reach 10 you have to stop. Okay, you are not going to check 10. Okay, you are going to reach the frequency only until the here only 0 to 9. Okay, so here if your digit becomes equal to 10, okay, then you have to stop. Okay, digit becomes equal to 10, then you have to stop. Okay, so this is your base case. Okay, so if we have processed all the digits, okay, so then after that in the result when you are going to add these these ways, okay, so you are only going to add those ways when your even sum, okay, when your even sum is equal to odd sum. Okay, so this is what you need to check. Okay, so here you are going to create one variable in which you are going to check the current sum. Okay, current sum with even indices. Okay, whatever the current sum that is coming up, so it should be equal to the current sum. Okay, it should be equal to the total digit sum divided by 2. All right, okay, and you are also going to make sure that your even position count is completely filled. Okay, even position count, so definitely if I am checking even, definitely odd is also going to be fulfilled for completely. So if this is nothing but equal to n plus 1 divided by 2. Okay, so if this case is valid, then just add the total number of permutations. Okay, this is one base condition that we have to check. Okay, so that's what basically we need to do, right? And there are some formulas that we are going to use, right? We are going to pre-calculate all these factorials. Okay, so there are n ways, right? So in our string, okay, so here see this example, this constant, right? So here nums dot length until 80. Okay, so we are just going to pre-calculate all this. Okay, so here let's suppose all the numbers are same. Okay, so in this case you are going to calculate n factorial, and here the frequency of this. Okay, all this, so 1 is occurring n times, so n factorial. But here if you want to calculate this n factorial, okay, so that simply means 80 factorial. Okay, until here, so you are just going to pre-calculate all these values, right? So constant size, this is a constant size. Okay, so how you are going to calculate factorials? So very easy now. So you already know that factorial of 0 is nothing but 1. Okay, and factorial of 1 is nothing but 1 into factorial of 0. Okay, previous, so it is nothing but 1. And factorial of 2 is nothing but 2 into factorial of 1. Okay, so this is nothing but 2 only. Then factorial of 3 is nothing but 3 into factorial of 2. Okay, so here 2 factorial of 2 you already know. Okay, 2, so 3 into 2 you're going to get overall result as 6. Okay, so this is what you need to do. Okay, so this is how we are going to calculate the factorial, right? And here this is also requirement, 1 by this. So this we are going to get like here, let's suppose if you are number like this, 1 into x factorial. So how you're going to calculate the factorial of this? Okay, so here you can also write it this like this, x minus 1, and it's a factorial, right? So how you're going to calculate? Okay, and here make sure now when we are going to calculate the factorials, just divide the total results with the modulo. Okay, this is given in the problem statement, right? So results can be very big, right? So here's I think it is mentioned here, right? Since the answer may be very large, return it to modulo 10 to the power 9 plus 7. Okay, so we are going to use that. Okay, so this is what we need to do, right? And here x minus 1. Okay, and here also take modulo. So you already know this is nothing but your Little Fermat theorem. Okay, and we have already discussed about this here. Okay, in this particular video. Okay, what is this Fermat's Little theorem? Okay, modular inverse using Fermat's Little theorem. Okay, so we are just going to apply the formula, and we are going to get the Fermat's this value. Okay, so this, how we are going to solve this? You are going to get the output of this if you already know the value of factorial of x. Okay, so what you need to do here, write factorial of the x, okay, whatever the value of this factorial of x, and you have to just take the power of, okay, here this, and here you have to take the power of what is the m value, -2. Okay, so this is nothing but your Little Fermat theorem. Okay, so you are going to get the output of this. So here factorial of x you are already going to calculate from here. Okay, and from that just power m -2. Okay, so this is going to give you the power output of this. Okay, so this is nothing but a Fermat's Little theorem. Okay, so this is the formula that we have already derived as part of this particular video. Okay, so this is what we are going to use this, right? And also you already know that this power can be very large. Okay, this power can be very large. So there is one way to solve this problem using fast exponentiation, right? And that is also being discussed here in this particular video, right? Fast exponentiation. Okay, so we are going to apply the same logic here. So here just like 2 power 80. So are you going to write it like this, 2 into 2 into 2 into 2 into 2, okay, until 80 times? So it is very big enough. This is not possible. Okay, this is not possible. Okay, so this is bad, right? It may be very big. Okay, so how you are going to solve this? So here you can also write it like this, 2 power 40 power 2. Okay, this is same now, right? You can also write it like this also, 2 power 20, 2 power 2. Okay, this so you can write here, right? So this is how you are going to solve this problem. Okay, so you can also break it like this here, 2 power 10. Okay, and here 2, here 2, and here 2. Okay, and you can also write it like this, 2 power 5, and here 2, then 2. Okay, something like that. Okay, this is how, like, now it's nothing but 32 into 32 power 2. Okay, then you are going to solve this part, then complete square part. Okay, so it is going to reduce your calculation time, right? So that's the logic behind this fast explanation. Okay, so there is some code for this, and we have already discussed that in detail as part of this video. Okay, so now let's move to the coding part. Okay, and I'm going to explain everything with code, right? So let's get started. Okay, so code is going to be a little bit lengthy, but don't worry, we will discuss every point. Okay, we'll discuss all lines, right? Whatever we are going to do. Okay, so here first, here do one thing. First create one variable int. Okay, and this int is nothing but the length of the input number. Okay, so here let's add the comment as well for your better understanding. Right. Now after that, int total digit sum. Okay, and this is nothing but the sum of digits in the input number. Okay, final int mode, and here just give int, and here 1 e power 9 plus 7. Okay, this is done. So this is nothing but the modulo for the large numbers. Okay, so modulo for large numbers. Okay, so this is done. And then after that, just take total half permutation set to 0. Okay, so total ways to arrange digits in even and odd indexed position. Okay, so for that I'm creating this variable, you can say long. Okay, since values can be very large. Okay, so here long total half, okay, permutations. Half permutation simply means I am dividing them in odd and even. Okay, that's the simple meaning of this. Total half permutations, and here set it to 0. So this is for that. Okay, and now here first let's write the code of the fast modular exponentiation, right? It is going to calculate using this base into exponent power mode. Okay, so here I'm just going to write the method for that. Okay, so int power mode. Okay, so in this there is one base and there is one exponent. Okay, long base, long exponent. Okay, so now we are just going to divide this problem in sub problems. Okay, so exponent. So here let's understand the code side by side. Okay, so here I am talking like this is your base, like here we discuss now. This is nothing but your base. Okay, and this is nothing but your exponent. Okay, so this is what you need to calculate. Okay, so I am writing a method to directly get the output of this. Okay, so here I'm writing that method. Okay, so here first 2 power 0, if I say, okay, if I say 2 power 0, then that simply means you have to return 1, right? 2 power 0 is going to 1 only. So here there is one base condition, right? So here if exponent, okay, if it is equal to 0, then in that case you have to simply return 1. Okay, this is done, right? Now after that you have to half the power. Okay, you have to half the power. So how you are going to half the power? So 2 power 18, you are going to write it 240, then here 220, then 210, then 25, then later on you have to write it 2 and here 2 plus dot 2 here. Okay, so yeah, for odd cases let me tell you. So 2 power 81 you can write it like this na, 2 into 2 power 80. Okay, this is right, you can write it like this now. So 2 dot 2 power 80. Okay, so here you can write it like this later on, 2 power 40 divided 2. Okay, so 1 2 is coming out outside, right, in case of odd, right? So here this is what you need to do here. So long half power you need to calculate. Okay, long half power you need to calculate. So here just you are going to first divide this in half. Okay, so here power mode, and here you have to write your base and you have to divide the exponent by 2. Okay, exponent by 2. Okay, you are dividing the exponent in half. Okay, so this is again you are going to pass here. Okay, the same thing, right? And how you are going to calculate the result? Long result is equal to half power into half power. Okay, half power into half power, and here value can be large, so here just do this. Okay, so this is done, right? So here one more thing, if your exponent, okay, if the exponent value, okay, exponent value, if I divide it with 2, okay, and the remainder comes out as 1, that's odd. So in that case how you are going to update the result? You are going to update the result as result into base one time. Okay, result into base, right? And here you have to write mode. Okay, mode. Okay, this is done. And in the end from this function you are just going to return what? You are just going to return nothing but result. Okay, so int is the return time, let's say int, and the result. Okay, int is the result, return type for this function, right? So this is what you need to return. Okay, so this is your first method. Okay, all right, so now this is done. So let's write few things inside this our main function. Okay, so here what you need to do first, just calculate the length of nums. Okay, and is equal to nums dot length. All right, so this is going to calculate the length of the nums. Okay, now after this what you need to do, you have to calculate the total digit sum. Okay, so here you have to write total digit sum and you are going to set it to 0. Okay, so this is done. Then after that you have to calculate the frequency of digits as well, right? So here you are going to write digit, and here you have to write frequency, digit frequency, and here you have only numbers from 0 to 9, right? So here you have to write new int, and inside this you have to pass 10. Okay, so 0 to 9 10 total, right? So now we have to calculate the frequency of each digit and compute a total sum, right? So for that purpose you are just going to simple run one loop. Okay, int I is equal to 0, I is less than n, and here I plus plus, and here after that inside this just first check what digit is there. Okay, so int digit is equal to num dot char at the index I. Okay, and here minus, and here you have to write 0. Okay, so this is done. Then you have to calculate the digit frequency. Okay, so this is also required now, how many times digit is there. Okay, so digit frequency, right, and here pass that particular digit, and here just increment that. Okay, so this is done. And then total digits we have to calculate. Okay, total digit sum, right? So total digit sum is equal to total digit sum plus that particular digit. Okay, so this is what you need to do, right? So this is done. Then after that you have to check now, if the total digit sum is odd, then no balanced permutation possible. Okay, so here you have to write if the total digit sum, okay, if modulus with the 2, okay, if it is not equal to 0, okay, if it is odd, that simply means you have to return 0. Okay, then it's not possible, right? Now after that here just pre-compute the factorials and inverse factorials. Okay, so this is what we need to do actually in all the competitive coding exams, right? So pre-calculate all this stuff. Okay, we are not don't want to calculate these factorials and inverse factorial again and again. Okay, so how you calculate this new int, since from 0 we have to take 0 to n we have to take, so here I'm writing n plus 1, right? and you already know that factorial of 0 is 1. Okay, this you already know, right? And then after that you have to simply run one loop now. For int I is equal to 1, I is less than equal to n, and here I plus plus, and here after this you have to write a factorial of I is equal to factorial of I minus 1. Okay, I minus 1 into I. Okay, and just don't forget to add mode. Okay, so this is what required here, right? Here like this mode. Okay, mod, right? So here we are going to calculate factorial. Now we have to write the inverse factorial using the Little Fermat theorem, right? So we are going to use Fermat's Little theorem. Okay, inverse factorial we are going to calculate. Okay, modular inverse using Fermat's Little theorem. Okay, so this is what we need to do. Okay, so simple formula, we already calculated the factorial now. So how you are going to calculate that? So here just copy this, paste it here. Okay, this line, so this, and here just change it, instead of factorial here just we are going to calculate the inverse factorial as well. Okay, so here you can say inverse and factorial. Okay, inverse factorial is equal to new here also here long now we are taking, so why I'm not specifying long here. Here specify long. Okay, long here, and here also it should be long. Okay, so now this is done. Then again you have to run one loop. Okay, so here just copy this, paste it here, and here you are going to start from 0, and it should be less than equal to n and I plus plus, and here inverse factorial you have to paste. Okay, inverse factorial of I you have to calculate. So inverse factorial of I is nothing but it's going to be power. Okay, we have to take the power. Okay, so I'm going to specify this one more function. Okay, power mode. Okay, and in this power mode I'm going to pass this inverse factorial of I, a factorial of I only we have to need, right? Factorial of I only is required here. And in the power, what I need, in the power I need to pass the mode value minus 2. Okay, so here mode minus 2. Okay, so this is the theorem for this. Okay, Little Fermat theorem. So here this is how I'm just going to calculate the inverse factorial. Okay, so this is done. Okay, inverse factorial, right? And factorial of I we are already calculating using mode, right? So no requirement here. So, and in the power mode also I will use mode. Okay, so there itself, so that we get only smaller value. Okay, so this is done. Okay, so this is done. Then after that once this is done, so how you calculate the total permutations possible for half even and half odd indices. So we have derived one formula, right? I'm going to use that formula. Total half permutations. Okay, total half permutations, and here a spelling mistake, right? PE, total half permutations is equal to total half permutation is equal to, here you can pass, here permutations, here you can pass factorial of even and odd. Okay, these two things, right? You have to pass. So here factorial of here inside this you have to pass n plus 1 divided by the 2. Okay, and here you have to multiply it with factorial of n by 2, right? And overall you have to take the mode. Okay, it can be very large, right? So here just copy this and paste it here. So this is how you are going to calculate the total half permutations. Okay, and now from here you can simply return what you are going to return. So you have to count the number of ways, right? So how you are going to calculate the number of ways? Count ways. Okay, so this is a recursion method that you are going to write. Okay, so in this recursion method, what you are going to pass, you are going to pass your numbers. Okay, so how many numbers that you are passing, so all that stuff you have to pass. Okay, so first you're going to pass the digit. Okay, so first you are going to start from 0 only, so then you have to pass the even position count. Okay, then you have to pass the current sum. Okay, initial current sum, then you have to pass the digit frequency. Okay, so here digit frequency you have to pass, right? So here you have to write digit frequency. Okay, so let's write the code first. Okay, so here just understand, here I'm passing, but I'm passing here inverse factorial. Okay, like that, just copy this. Okay, here copy this, paste it here, inverse factorial I'm going to pass, and here I'm going to pass let's use a memoization. This dp is nothing but going to be my memoization array. Okay, so in this dp we will check now that if I have already checked that particular digit, okay, 0, and how many times it occurs in the even indexes, okay, even position count. And here I will check that what is the current sum. Okay, current sum. So we have to check the sum as well, na, right? We have to maintain the sum, how much sum we are getting here, okay, in this step, and in the order it should be matching only then we have to calculate that way. Okay, so here current sum. Okay, so only these three parameters are changing, na. So what are the three parameters that are changing? So digit, okay, what digit we have, and the even position count, okay, what is the count at even positions, okay, of this particular digit, and the current sum, okay, current sum. So only these three things are changing. Okay, so if we have already pre-calculated this value, then I will store that now. I don't want to calculate it again and again. Okay, so I'm going to use this memoization for that purpose. Okay, so here let's do one thing, let's define it here. Okay, let's initialize the dp array here. Okay, so int 3d array, okay, dp, here new int, and here you have to pass what, 10. Okay, and here you have to pass n plus 1 divided by 2. Okay, and then after that here n plus 1 divided by 2 plus 1, and here after that you have to pass total digit sum plus 1. Okay, total digit sum plus 1. Okay, you have to just fill all the values with -1 initially. So here int you can use simple for loop as well. Okay, and here you can use for each loop as well. Okay, so 2d dp. Okay, so first I just break into 2d array, okay, this one, and then just break it to 1d array. Okay, so for int 1d, okay, and here 2d 2d. Okay, so now after this, inside this, just I'm going to fill all the values with -1. Okay, so here you have to write arrays dot fill 1d, and here -1. Okay, that's it. So this is what you need to fill. Okay, so this is done, right? And then after that, was this done, so now let's define the extra things that we have created, right? The functions like count ways, how we are going to define this count ways. Okay, so I'm going to write the code for that. Okay, so count ways. So here what you need to do, how you are going to calculate the number of ways. Okay, so count ways we need to check, right? So here until here this is done. Okay, so now here dp recursive function to count the valid permutation. Okay, so here you can write public, here you can write public count ways. Okay, and inside this what you need to pass, you need to pass the digit. Okay, digit you are going to pass, and then even position count you are going to pass, even position count you are going to pass, then you are going to pass int cursor. Okay, and then you have to pass digit frequency. Okay, so int digit frequency you have to pass. So here just pass this. Okay, here you can pass int digit frequency. Okay, so here you can take it as, here we are, how we are taking it, we are taking it in a long. Okay, so here just change it to int now. Why I'm taking long, digit frequency. Okay, so int digit frequency, right? So here take int only, and then after that what are the other things that we have to pass? So here we have to pass the factorials. Okay, so where I'm defining factorial. Okay, so long inverse factorial we have to pass. Okay, so here just pass this. Okay, so paste it here, long inverse factorials. Okay, so here let's keep it a little short, factorial. Okay, done. And then after that we have to pass, we are passing dp array, right? So here int, it's 3d, right? So like this you have to write. Okay, now inside this you have to write the code. Okay, so first base condition, if we have processed all the digits. Okay, so if we are starting from 0 now, so if your digit it becomes equal to 10. Okay, so if digit becomes equal to 10, then here inside this you have to check for the valid distribution of digits and equal sum in both halves. Okay, so here just one more if condition. Okay, if cur sum is equal to total digit sum divided by 2 and even position count. Okay, even position count if it is equal to n plus 1 divided 2. Okay, so that simply means that first half we have filled all the digits, right? Okay, and we have the sum half also, right? So that simply means odd is always going to be equal only then, right? If we have filled all the digits in even half with the sum as half only, okay, of the total, then in the other half there will be half sum only, right? So this is what we need to check. So in that case only we have to just simply return what we have to simply return the total half permutations. Okay, int total half permutations. Okay, so here what we have to return, we have to return total half permutations. Okay, so just copy this total half permutations. Okay, this is done. All right, so now this is done, right? Now after that, this is one base condition. Okay, otherwise you have to simply return 0 now here. Okay, if it is not valid. Okay, so return 0, right? So now here we have to also return the already computed results. Okay, so if this value, okay, so here where we have defined digit dp. Okay, here dp we have defined here now. So if the dp, okay, and here we are passing digit this even and current sum. Okay, so if we have set all the values equal to -1 now, if any value is not equal to -1, that simply means that we have updated that later on. So here I'm just going to pass if dp of digit and here even pos count, and here inside this after that you have to pass cur sum. Okay, and here just check now if this value is not equal to -1, then simply means that you have pre-calculated this value. So in that case you have to just update what you have to just return this now actually. So here just return dp of digit of even post count current sum. Okay, that's it. Okay, this is done. All right. Okay, so now here this is done here. Then here how you calculate the number of ways. Okay, so long ways. Okay, just set it to 0. Long ways is set equal to 0, right? And now after that you are going to try placing current digit in even index position. Okay, so in even index only we are checking if in even index we place it 0 time, 1 time, 2 time, okay, all that stuff. So here let's create the index like this only, placed in even. Okay, placed in even. Okay, placed in even. So let me just copy this, placed in even. Okay, so if I placed any digit here in the even 0 time, okay, starting from 0 only, then this placed digit in even, it should be less than equal to the, here we have to take math.min. Okay, math.min of the digit frequency. Okay, so here digit frequency of that particular digit. Okay, or the number of spaces in which we have filled. Okay, so we have to just fill only the minimum among them, right? N plus 1 divided by 2. Okay, done. And here n plus 1 divided by 2, here done. And here minus even pos count. Okay, and this is done. Okay, this is done here. And here placed in even digits plus plus. Okay, this is done. Okay, so placed in even, it should be less than the math dot min of digit frequency of that particular digit, and here n plus 1 divided with 2 minus even post count. Okay, so whatever the minimum only we need to place. Okay, so that is the only valid case now. Here if in even you have just 3, okay, and the frequency of one particular digit, okay, 0, let's say it is 4, then you can't place it 4 times now. You can only place 0 to 1 3 times now, 1 to 3 times only, right? If frequency of 0 is 4, then you can't place here, you have only 4 indices, right? So you can't place, so that is why I'm taking mean. Okay, one variable int placed in node. Okay, so placed in odd is equal to, here you can write digit frequency, and here you have to pass the digit, okay, of that particular digit, but is the frequency, and minus placed in even. Okay, so this is what you need to write here, placed in even. All right, and now you have to calculate the inverse factorial for even and odd placements. Okay, odd placement, so you can simply write long denominator. Okay, so denominator, okay, long denominator, here you can pass inverse factorials placed in even. Okay, so here just copy this, here we are passing na inverse factorials, and here inside this you have to pass placed in even. Okay, placed even into placed in odd. Okay, so here just copy this, paste it here. Okay, and here this, like this. Okay, and here like this, and here it is placed in odd. Okay, and here just take the modulus. All right, so this is done, mod. Okay, so now after this you have to divide this in sub problems. Okay, so how many sub problem base? Okay, so here you have to write long sub problem ways, okay, is equal to count ways, right? And in this count ways you have to pass na, so next time your digit is going to be +1. Okay, digit +1. All right, and then after that you have to pass the even position count. So even position count is equal to even pos count, and if you have placed in even one time, okay, so placed in even plus placed in even, how many times you have placed that in particular even. Okay, so this what you need to add, okay, for the next step. And the current sum you are going to update as cur sum. Okay, we have to keep track of this one as well, current sum plus that particular digit into placed in even, how many times we have placed that in even. Okay, digit into placed in even, so placed in even. All right, this is done, and then you have to just pass the digit frequency. Okay, so here just copy this. Okay, digit frequency, copy this, paste it here, and then you have to pass nothing but the inverse factorials. Copy this, paste it here, and then after that you just need to pass the dp. Okay, so here dp, right? So this is what you need to do here. Okay, so this is done, and then after that you have to just how you are calculating the base. So simple now, base equal to base plus. Okay, every time we have to just base, add this base. Okay, so how many sub problem base we have to calculate here? Okay, we have to just multiply that with denominator. Okay, simple formula, sub problem base into this denominator that we have calculated here. Okay, place it here, and just here take the mode as well, right? So here this just write mode here. Okay, mode, and take this complete mode as well, right? Okay, this complete mode as well, so here mode. Okay, this is done, and then from here you can simply return int base. Okay, this is nothing but your base. Okay, here ways you have to return, so you are just pass this value now, update this so that we don't need to recalculate. Okay, so here ways you are returning, and just pass this value here inside this. Okay, that's it. Okay, let's run it and see if the encode issues. We'll see. So yes, there are some issues. So here we are getting some issue. So here we didn't write int na, return type should be int. Okay, so let's run it again. So here there is some issue, it is num only. Okay, let's run it again. So see, all the test cases has been accepted, right? Now let's submit it. So code is very lengthy, right? So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.